All right, next lesson is over limiting reactant or reagent, which is an older school term. So you need to recognize both reactant and reagent. They mean the same thing. So what limiting reactant is basically this. In real life, when we're working with our reactants, we mix two chemicals together, and one of them runs out before the other one, okay? Some of it's based because of the mole ratio from the balanced equation and molar masses, and so these types of problems are called limiting reactant problems, okay? And if you are understanding the stoichiometry problem so far, it's not going to be any harder. It just is going to work an extra problem is all you're going to end up doing, okay? But let's talk about some definitions first, okay? Whichever reactant produces the smallest amount is the limiting reactant, meaning once it runs out, I can't keep making it, okay? So the limiting reactant is what runs out first. It controls how much product can be made. So let me give you a real world example. Let's say that I have a whole jar of peanut butter and I have only 4 slices of bread, okay? So if I wanted to make sandwiches, I would run out of the bread before I would run out of the peanut butter. And so my bread would be my limiting reactant, okay? Let's say I go to the cabinet and I want to make a double batch of cookies, okay? So I get out all my ingredients and I have flour and I have chocolate chips and I have all the things I need, and I'm going to double my recipe, and I go to my refrigerator and dang it, I only have 2 eggs, okay? So my eggs are going to be my limiting reactant. I can't keep making cookies without the eggs, and so the eggs would limit how much I could make. All of those other things in the cookie ingredients would be my excess reactant, meaning I'm going to have leftover of those, okay? So that's an example of that, okay? So basically, it's very simple as far as what we did from yesterday. We're just going to work the problem we're going to work it twice with both reactants, and then we're going to see whatever gives us the smallest answer. Okay? All right. So here is an example. We're only going to work one of these because that's all we need to do. Now, on one of these, you can cross this out, how many grams of excess reactant is left. We will not be doing that. Okay, it's for pre-AP. We don't have to do that. All right. So we have 25 grams of each one of these reactants. We have carbon and silicon dioxide. Okay, so we're going to work it both ways, solving for what it's asking for. Okay, so it is ultimately asking us for how many grams of the silicon carbide is going to be produced theoretically. So that's what we're looking for. Okay, so we're going to work it once with 25 grams of carbon and then 25 grams of silicon dioxide. All right, so we start with 25 grams of carbon, and we're going to do our stoichiometry problem. 12.01 is the molar mass of carbon. And see how nice of me, the equation is already balanced. So I want to get rid of moles of carbon now, so I'm going to put moles of carbon on the bottom. And I'm trying to get to moles of silicon carbide. Now I go look at my balanced equation. I have a 3, so 3 goes here. And I have a 1, so a 1 goes there. Okay, got rid of moles of carbon. It's asking for how many grams, so I got to use molar mass of silicon carbide. So 1 mole of silicon carbide, and then I add up silicon plus carbon, and I get that molar mass is 40.10 grams of silicon carbide. And then I do that math, multiply the top and divide by the bottom, and I get 27.8 grams of silicon carbide. Now, I do not know if that's my answer. I have to work 2 problems, okay? There's no way to know which is your answer without working 2 problems. And I'm going to tell you that if you only work 1 problem, you will get it partially wrong if you do not have 2 problems, because you do not know how to do this without doing both of them, okay? So now let's do 25 grams of the silicon dioxide. All right. Got to use the molar mass because we got to get to grams to moles, and the molar mass of silicon dioxide is 60.09 grams of SiO2, 1 mole of SiO2. Okay, For those of you wondering, if you're still wondering where I'm getting that number, it is the molar mass, which is added up from the periodic table, okay? I have gotten rid of grams, now I'm in moles, so now I can use my magic mole ratio that gets me from one item to the next in the problem. So I have moles of silicon dioxide, and I'm still trying to get to silicon carbide, so I'm going to work it, that part's going to be the same. Go look at the balanced equation. In front of silicon dioxide there's a 1, and still a 1 in front of silicon carbide. Cross out moles, and now the last step, of course, is going to be the molar mass of silicon carbide. All right, and so I do that math, multiplying the top, dividing by the bottom, and I get that my answer is 16.7 grams of silicon carbide. That is definitely smaller, so that is actually my answer. So that's the one I box. Do not box both answers, okay? Box the smallest one. Whatever gave us the smallest one is our limiting reactant. So silicon dioxide is the limiting reactant. And that's because I will run out of that first and I can't keep making product. All right, so do the problem again. Let me reiterate what I said. Work the problem with both reactants, solving for the product that they asked for. And then whatever gives you the smallest answer, box the smallest answer. You must indicate which one is the right answer. So box the smallest answer, and whatever gave you the smallest answer is your limiting reactant. All right, so this was a nice and sweet and short video lesson. Okay, next one will be tomorrow, and it's over percent yield. It's one that I recorded last year, so it's going to look a little bit differently than these last couple of ones, and because it's an old one, I got something to look forward to. It ends with jokes. All right, hope to see you soon.